Okay, here's a question that I'm guessing nobody understands, and it's because no other question like it has come up before or since. It involves a little section on trigonometry, which is in the book, which we kind of had a look at, and then I imagine most of you probably forgot. And I can understand that because at this stage it's quite difficult to take in. F of x is cos x, g of x is sin x, and h of x is tan x. Now we need to understand what cos, sine, and tan look like actually to solve this. Um, because we're used to using cos, sine, and tan to work out ratios for triangles, to work out opposite and adjacent and hypotenuse, but they're actually sort of much deeper functions than that. And they don't just typically when we do cos and sine, the answer we get is between 0 and 1 because we're doing the ratio of two positive sides. But bizarrely, once you start getting into angles beyond 90 degrees, you'll find that things like cos, sine, and tan, you can start getting negative answers. And if you think, well, how can opposite over adjacent be negative when we're talking about lengths? That's because cos, sine, and tan aren't really about opposite, adjacent, and hypotenuse. That's just a method we use for working out a particular type of question at GCSE. Anyway, enough backstory. How do we solve this? Well, what we need to know is what these graphs look like. Cos of x, if you type in some values into your calculator, you'll notice that if you type in cos of 0, you get 1. So cos of x starts at 0, 1. If you do cos of 2, you get a value a bit less than 1. If you do cos of 10, you get a value a bit less than 1. If you do cos 30, you'll get 0.86. And then gradually it comes down and down and down as you increase x until you get to cos 90 when it becomes 0. And then if you increase beyond that, you type in 90, you do cos 95, you start getting a negative amount, cos 100, cos 120, you get more and more negative amounts until you get to 180 when cos becomes minus 1. So between 80 and 100, between 0 and 180, cos does this. And it actually carries on doing this. So after 360 degrees, it comes back to where you started and the whole process repeats again. I won't justify any more than that, but that's cos. Sine, on the other hand, starts at 0, so sine of 0 is 0, and then increases as it goes up to 90, and then goes back down again at 180, dips here, and then comes back to where it started at 360. And so both of these curves are exactly the same shape, even though it might not look like it. They're that sine wave shape, and those of you who've studied a bit more music might be familiar with sine waves. But yeah, they're these regular wave shapes, and they're very important. You'll do a lot more of this in A level. And then it talks about tan x. Well, tan x is the ratio of sine over cos. So when x is 0, sine x is 0 and cos x is 1. So tan is going to be 0 over 1. So tan is going to start off at 0 as well. And then as sine increases and cos decreases, tan gets bigger and bigger and bigger and bigger. Um, when sine and cos are equal, then tan x is 1, and that's actually at 45, although I've drawn this pretty badly. And then tan shoots off, so that if you type in tan 80, tan 85, tan 87, it's getting bigger and bigger again. And then tan repeats this pattern actually constantly, but you don't need to worry so much about tan. Let's take those off before I upset you. So anyway, you need to know tan as this. Now, it says find the range of f. The range is the set of possible outputs, so the set of values you can get for cos x between 0 and 180. Now, even if you didn't know what cos did, you could actually figure this out on your calculator. If you typed in cos of 0, you get the output when x is 0, and you'd find out that it was 1. And then if you tried 180 and you did cos of 180, you get minus 1. And if you checked all the values in between, you notice that it covered the range values in between there. So that would tell you that the range of f, the output values of x, lies between minus 1 and 1, between 0 and 180. And this is given that the range of x, we can see that on the graph as well, between 0 and 180, cos goes from 1 down to minus 1. So the range of outputs is 1 to minus 1. Given that the range of h, that's the tan x, is the same as the range of g, which is the sin x, find a value of p and a value of q. So sin x between 0 and 90 goes from 0 up to 1. You can type in values on your calculator and see that it goes from 0 to 1. So that's the range. So the range of g and h is between 0 and 1. So then we need to work out for what values does tan x go between 0 and 1? Well, tan of 0 is 0, as we said. And when sine and cos overlap is at 45 degrees. So it is, in fact, P to Q can be thought of as 0 and 45. Now, that's an incredibly difficult question to understand if you don't really know about the trigonometric functions. What I would say is that if you're trying to find the range of a function that you don't really know very well, plug in some values, start with the first value and the last value, and then plug in some values in between. And it's the set of possible answers that tells you what the range is. So you can actually work out the ranges for cos and sine without being familiar with the functions. And then to find the set of values that you plug into tan x to get between 0 and 1, start with 0 and just keep increasing tan x until you get to 1, and you'll find that it's 45. If you know your trigonometric functions, brilliant, but I'm not expecting you to at this stage. It's more of an add maths thing, and an A-level maths. Please ask me on this question if you're not happy, because I can direct you to some more resources.